All right, physical science students, we are getting into the last chunk of our force and motion unit, and we're going to be getting into Newton's laws. So let's get to it. All right, so the first few of these is going to be a review. Remember that net force? Remember, net means like the total or combined is the combination of all the forces acting on an object. So the net force of this example below is going to be 1 because I have 3 here, 2 here. This is going to be stronger, so the box, whatever object it is going to move to the right. This is 5 because they are both moving in the same direction. So it's 5 newtons. Here's 1 newton because this is going to be bigger, causing the box to move to the right. This is going to be 5 newtons because I have each force moving in the same direction. Like so. All right, so remember our balance forces cancel each other out, and that's what happens when the two forces are the same. So there is no movement, so no motion, 0 newtons. An unbalanced force, the forces don't cancel, and this just means that our total force is more or greater than 0. So you can see that this is bigger. It's 2 newtons bigger than 3 newtons, so it's going to make it go to the right, and it has 2 newtons charged. All right. So, who is this guy, Newton, and why do we use his name for a unit? So, every motion you observe or experience is related to force. And Sir Isaac Newton described the relationship between the motion and force in 3 laws. And that's what we call Newton's 3 laws of motion. All right, first law. An object at rest will remain at rest, and an object in motion will remain in motion unless acted on by an unbalanced force. So this is what our car lab was about. So the car slamming into the books, was that unbalanced force. So the car kept going until it hit the books. This is also called the law of inertia. So inertia is a tendency of an object to not move, to resist any kind of motion, which is why when you're in the car and you have the seatbelt on and you have to slam on the brakes, you lurch forward, like your body moves forward, even though the car stops. So pulling a tablecloth up from under a set of the table, so you'll see people pull like the tablecloth under and the dishes still stay there. The objects on the tablecloth resist the change in motion because of inertia. And then here is our nice little example. High-tech video right there. The guy goes into the wall. The wall, it has more force than the car, which causes the car to stop and the man to go forward. All right, Newton's second law. So this law describes the relationship between force, mass, and acceleration, which sounds super fancy, but it's really not anything too crazy. So the unbalanced force acting on an object equals mass times acceleration. So this is saying it's going to take, if your mass is big, like it's a big object, it's going to take more force for it to go fast. And if your acceleration's big, you're going to have less mass to equal that force. So here's an example. So more force you put on an object, the faster or the more acceleration it goes. So if I throw a ball really hard, let's say 10 newtons, then the ball goes really fast at 20 meters per second squared, my acceleration. If I throw it softer at 1 newton, like not as much effort goes into that throw, then the ball goes slower. So we're going to do some practice problems right here. I'm going to pause that. So what's the necessary force for 60 kilometers of automobile to accelerate towards that? And so on and so forth. And we'll do some practice problems later. We'll do more practice problems as we go through, of course. But I just need to multiply. The ball accelerates downward at 9.8 meters per second squared, because remember, that's our gravity. If the gravitational force acting on the baseball is 1.n newtons, then the mass is 0.14. And I'll just give you the answer for the last one, because we are going to do multiple examples of these problems. All right. So for every action, there's an equal and opposite reaction. This is Newton's third law. So the cat's cradle is the example. And of course, it's not working. That's cool. So I'll go to the next slide. But you know cat's cradle. You will, whoopsie doozles. You'll take the silver ball and you'll throw it back and you'll slam it, and then the energy goes through and pushes it to the other side. Kicking a soccer ball, that also forces come in pairs. So the kick from my foot causes the soccer ball to move. Here are all the examples for Newton's third law. Like there's just a bunch. Pushing against a wall. So I push against the wall pushes back on me. Swimming, I push the water backwards, and therefore I'm able to move forward. Simple things like standing up. I push against the ground pushes up against me, and then our rocket launches. So the fuel emission from the gas combination, fuel combustion, pushes the rocket up, and the gases pushes the rocket down like that. All right, and here is our video. I will put that as a separate Edpuzzle for you to watch. All right, so what law is this? If you said first law, you're correct. And there's only 3 laws to begin with, so your odds of getting it are pretty good. This is our law of inertia. What law is this? We have an action and reaction. That's Newton's third law. And kicking a ball, applying to equal and opposite forces. That's also Newton's third law. Anytime you see a mass, anytime you see acceleration, that's going to be Newton's second law. So how much force is it going to take for this guy to push this car? And that is our math formula, which we're going to become more comfortable with. Law is this, action, reaction. That's number 3. All right, and that is it. So I know I went through it kind of quickly, but we're going to do lots of activities and worksheets to help you get better acquainted with Newton's laws, and I will see you guys in class.